Thanks. So I'll talk a bit about the study, how we use the language models in to understand if we can identify vulnerability in software code. So one of the reasons why it's so problematic with common vulnerability enumerations is that they are very specific. Many of them contain only many of them don't contain any code examples, and those that contain some code examples are either very specific code examples or very small code examples. So you cannot really train any machine learning classifiers on that. There are tools that try to do that, but then what turns out is that they only can validate very, very few of those vulnerabilities. So I will skip the theory, as I mentioned that in the session before lunch. The whole idea is based on the fact that we could extract language embeddings from big models like the GPT-3 model or others, and we could compare the context between different programs. And by comparing the distances in between programs, we could try to reason whether something is vulnerable or not. So that theoretically looks very nicely, but in practice, it looks like trying to look for a needle in a haystack. So this picture is a visualization of one commercial product, Cloudera, which is actually even in open source. It's a cloud block. I'm sorry, not block, but Dropbox kind of collaboration system. And here we are trying to look for similarity between different kind of lines. And you don't even see those lines because they are very, very small in the whole bunch of all other kind of lines. But the similarity between lines could be identified by using, for example, cosine distances, or like GitHub Copilot by building other neural networks on top of that. So what we did in our study was that we actually tried to look at those small examples that we have from secure design patterns and vulnerability enumerations, and try to look for those patterns in larger code bases. Something that's very, very tricky to do if you don't have things like language models, for example. So this is an example of how that actually works. So we take a design pattern that has been described somewhere, or we take a commandment for secure programming from companies, or an example of commandment or design guideline that talks about security. We identify the code that is related to it. We identify, for example, in this case, in the secure design pattern, it's an example of the code that's been provided as part of the pattern, and it shows that you can encode or encrypt every character using a very simple operation. And even that provides a much more secure way of logging your messages than just having plain text. And then if we do that, if we use this kind of code as a reference, we could look at other implementations, like this one, which is completely insecure, and this one, which is secure, but the operator is basically a bit different, right? And by looking at those different modifications, we could see if those language models can provide us with an information in terms of, for example, in this case, cosine distance between secure and insecure code. So if we compare that first example, the reference code, as I call it, and if we try to calculate the distance between that code and the secure code, then we could compare that distance to insecure code, we could see that the distance to the insecure is a bit larger or longer. And of course, that modification was a really tiny modification, so the distance is also very, very similar, so to say. But that basically shows that there is some value in this kind of approach. Now, this is a very school example, so of course, should be a bit more tricky for real companies. So for the companies, we actually identify the entire chain of or a pipeline for processing the code, creating those examples, and actually even looking at the results of those distances. Simply because if we analyze the code base, there is 3 different reference or three different reference data code bases that we need to use. We need to use examples of code that has a vulnerability. Then we need to use an example of a code that looks almost the same but doesn't have that vulnerability. So basically secure code. And we have to mix that code with the code that comes from a database, from a code base that is similar to the product that we are trying to evaluate, but not identical. Simply because we want the language model to try to embed the secure and insecure patterns in the same embedding space. If we have completely different patterns, they will be quite far away, so we won't be able to look at them and compare them. And if we apply that to a code base, we get something like that. So this is a code base from Siemens Gamesa, and you could see that the blue dots is their product. The red dots are insecure code example, and the green dots are secured code example. And then this code is similar to those in the most cases. Now, the reason why this is like that is that we've analyzed the entire code base. So every dot is one module, but we have only checked for one kind of security. And that kind of security is SQL injection in this case. So if we look at this kind of area, we could, and we looked at during the visit, it was that, of course, this kind of code contains some sort of SQL statements, could be directly or could be as part of a string or as part of a parameter. And this is the code that contains some sort of database operations from the company, meaning that these models actually try to understand in some way the connection between SQL and database operations, because it was trained on larger code bases. And then, of course, that code database is probably related to some sort of code that contains persistence mechanism, but not really database, and so on and so on. So that spectrum is somehow continuous to some extent. Of course, every module is similar to some other module, but not all of them to everything. And if we extend that to the analysis, how we actually decide if something is secure or insecure? Well, what we do is that we take our examples and take the analyzed code, and we try to plot the distance of our code, for example, those two dots, to secure and insecure code. I'm sorry, in this case, this is the dot that I'm looking at. So I take this yellow dot over here and try to see if that's surrounded by secure or insecure dots. And then I could see that in this case, the top three closest modules are actually secured code examples. And this dot is actually a secure code example as well. I mean, I prepared that, so I know what I'm looking for, right? And if something is insecure, then it could be placed in another point. Then that could actually be placed over here. So we see that for an example that I prepared, the code that is vulnerable, I mean, it's closest to the three other vulnerable code reference code bases. And by doing this, I can decide whether something is actually secure or not. And for these examples, I actually modified the examples that we had from the company. And if we look at extending that to even open source components, so here we are analyzing, using this kind of methodology, we're analyzing an open source component that contains an HTTP server that is used in embedded systems, that is has been used at the company. And in this case, we are trying to look for something that's called an input validation vulnerabilities. So sometimes the input could not, maybe it's not validated. And in this particular case, we actually found one. And that particular case is that we are never really checking the size, whether the size of the data that we are getting from the server and from the packets is actually the size that it's supposed to be. So this particular code could actually cause a vulnerability that could result in buffer overflow. So one could put more data and actually start executing that code at some point of time in this particular server. So this is the kind of things that we do. And then we also did it at the company, where we actually look at all kinds of software, all kinds of systems. And then in that particular case, we actually found no insecure examples, but that's only good for the company. And if we look at distances between those, we could also see that those kind of code examples are quite often part of the secure or closer to the secure than non-secure code, so to say, to validate. So to summarize, as you see, this was a first try of this technology on or those algorithms on the actual commercial code. In the next sprint, we are trying to do this even more examples. We are trying to both automatically extract more cases of vulnerability from CVEs, and we're going to visit Axis to test if they have any vulnerabilities in their code, train on their code, and we're going to take a look at more advanced product-related examples. So not only per function, but even per maybe subsystem or things like that. And with that, as I promised, I'm even catching up with time. So thank you.